Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. If you feel like you might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in.
So the first question here is, why is a variable resistor used in a circuit for a dimmer bulb? So the whole point in a variable resistor is you can change the resistance of that component, which means you can change the resistance of your circuit. And the point of changing the resistance of your circuit is so that you can affect or control the current flowing through your circuit. If you increase the resistance in your circuit, you'll decrease the current, and if you decrease the resistance in your circuit, you will increase the current, which means for something like a dimmer bulb, you can affect/control the brightness of your bulb. I can turn that resistance right down, that will make the bulb shine brighter, or I can turn the resistance right up and that will make the bulb dimmer. Okay, next question on the right, what is the difference between a diode and an LED? Well, LED just stands for light emitting diode, and the only difference is it emits light. Both of them, the defining feature is they only allow the current to flow round in one direction. Okay, which component should be used to find the resistance of a component? So talking about finding the resistance, calculating the resistance, we'll do in much more detail in the upcoming topics. I just thought it was worth mentioning here because it gets asked quite a lot. So you're going to need an ammeter and a voltmeter, because your resistance, or how to calculate it, involves this equation here and involves therefore finding voltage and current of your components. Remember to state that your ammeter should be in series with the component and your voltmeter should be in parallel with the component. Okay, explain what is incorrect about the following circuit. So your cell, that's correct, the long side is positive and the small side is negative. However, your current should be flowing round from positive to your negative. So these arrows are the wrong way round in this circuit. They should be going anti-clockwise, so it's the direction of the current. Put a diode into the circuit in the correct direction. So I've just redrawn the circuit here at the bottom. That diode I've put in there, I've put the arrow on top, not because it should have an arrow on top as a component, but just to show you that's the direction my diode is pointing in, and that's good because that is the direction my current would be flowing in, given that the long side of my cell is on the left hand side here, so it should be flowing around in this anti-clockwise direction. Okay, a student wants to conduct an experiment of how resistance of an LDR is affected by distance of a light source. Do an experiment and explain what you would expect. So the experiment needs to have the LDR in it, and it needs to obviously have a bulb in it as well. But also I'm going to be trying to find the resistance of this LDR. So in my circuit setup here, I have stuck an ammeter in series with my LDR and a voltmeter in parallel with my LDR so that I have a way of calculating the resistance of this thing. That black dot there would represent a bulb. I'd have to have labelled that in my exam. And then I also need a ruler to measure these distances. It's really important when you are designing an experiment in your exam, you tell them what piece of equipment that you'd need to use to measure that thing. So here I've got voltmeter, ammeter and ruler, all pieces of equipment that I need. And then what would I say? Okay, I'd say something like measure the current at voltage at the original distance away from the LDR, and then move the light in maybe, I don't know, 10 centimeter intervals, so regular intervals, and record voltage and current at each. Then I tell them how I'm finding the resistance. So if there is a relevant equation in one of these questions, you should state it, V equals IR. I should have gone a step further here and written, therefore, R is V over I. So I'm taking all of these voltages and dividing them by their respective currents to find the resistance. Then say repeat and average, okay, if it's appropriate to do so for your experiment. Now, what am I going to expect? What I'm expecting as I increase that distance, the resistance should get higher and higher. Why? Because as I increase that distance, the light intensity that is incident on my LDR will get smaller and smaller, which we should know increases the resistance of your LDRs. Okay, name one household appliance that uses a thermostat, explain how it works and what happens to the resistance of the circuit as the kettle boils. Brilliant. So my mistake in that question, I've already answered my own question, which is I'm going to talk about a kettle. Of course, it doesn't have to be a kettle. Maybe it's a thermostat that controls the heating. Any temperature sensitive circuit would work here. So let's talk about a kettle. So as the water temperature increases, the resistance of your thermostat in your kettle will decrease. And at a certain point, a certain lowness, if you like, for that resistance, that will trigger your circuit to cut the supply off to your kettle. So to stop the kettle receiving any electricity when your water has boiled. So when that temperature has reached 100 degrees. So yeah, these are how thermistors work in temperature sensitive circuits. You don't need to explain it in any more detail than that. Okay, one Christmas Joe realised that one of the bulbs in his fairy lights was out. He wants to know how the lights are wired. Explain to Joe how you know whether his bulbs are wired in series or parallel, and explain what would have happened if they were wired the other way round. So, Joe, I think that your lights are wired in parallel. Why? Because only one of them went out, which means all of the other ones remained on. That's only possible in a parallel circuit because they all have their own separate branches that they can then complete the circuit. So, if they had been wired in series, I would have expected them to have all gone out because you would have basically made a gap in your circuit. You would have no complete circuit for your current to flow.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets and completely for free, so why not?
Tips and tricks for this section then. Flashcards for components, yeah, just make some, make sure you know how to draw these. These are relatively easy marks to gain if you can. Ammeter and voltmeter, those ones are particularly important because when you're drawing them in a circuit, you need to put your ammeter in series and your voltmeter in parallel. And that's why I've written there correct place. And resistance, yeah, using V equals I times R if it asks you how from a circuit you're going to calculate the resistance of something. So that's when you talk about, oh, you need an ammeter, you need a voltmeter to measure your current and your voltage, and then you use this equation to find your resistance. Okay, LDR and thermistor, opposite to resistance. Yeah, just quickly, the pattern for both of these is the same, and it's as their property increases, the opposite happens to resistance. So as temperature or light intensity increases, resistance decreases. Okay, so just a way of remembering, as those properties increase, resistance decreases, so it's the opposite. Complete circuit for current, yes. When you're mentioning current, why it would or wouldn't flow, or what stops it from flowing, if you have a gap in the circuit or if you do not have a complete circuit is the right terminology to use, then your current will not flow.